Welcome to College Algebra. In this lecture video, we're going to talk about something called a determinant and Cramer's rules, and we will do some matrix operations. All right. So, what is a Cramer's rule? Cramer's rule is just another way for us to solve our system of linear equations. And the way how you do it is using the idea of a determinant. So, what's a determinant? Determinant is a numerical value. Okay. So for a determinant of a 2x2 matrix, where my matrix A here is A of 1, 1, that means first row, first column. Okay, and the way how we're going to find the determinant of a 2x2 matrix is denoted as, this is not an absolute value, okay, this is a determinant of my matrix A, which is take the A11 entry, okay, take the 1, 1 entry, multiply the 2, 2 entry. So we basically multiply them diagonally this way, then minus the 2, 1 entry, multiply the 1, 2 entry. Okay. Determinant only works for a square matrix. Okay. So it gotta be a 2x2 or a 3x3. So before we go into the calculator to find the determinant, let's take a look at this particular example. Find a determinant of the matrix. So we take the 1, 1 entry, multiply the 2, 2 entry. So that will be, so the determinant of my matrix A will be 3AC times 3BD, then minus the 2, 1 entry, multiply the 1, 2 entry. Okay, it has to be in that order, okay? So that will be 3BC times 8AD. Alright, let's simplify this expression a little bit. Okay, 3 times 3 is 9. AC times BD, that would just be ABCD. Minus, okay, 3 times 8 is 24. BC times AD, so that will be ABCD again. Alright, if I combine like terms, 9 minus 24, yeah, it's going to give me negative 15 ABCD. Okay, that's all we have to do. Alright, so for a 2x2 matrix, what we can do, I'm going to show you how to do this in the calculator. So what I'm going to do is go back to my matrix. Okay, edit. Press enter. A 2x2. So I'm going to type in my square matrix. Alright. Come out. Second quit. Come out to the home screen. Go back to the matrix. Go to math. And this time we'll look for number 1. DET. Determinant. Go back into the matrix and choose number 1. Determinant of my matrix A, negative 425. Okay. So how they figure it out is take this one times that one minus this times that. That will give me my answer. Alright. Now to find the determinant of a 3x3 matrix, okay, that's a little bit different. It's a little bit tricky, okay? This is a little bit tricky how we go about finding it. And so if you read the homework, okay, it will actually show you exactly how they do it by hand. So I'm going to go to the homework real quick and just put up one of these problems in chapter 10, one of these sections in chapter 10. I'm going to just explain to you real quick. Finding a 3x3 matrix. Alright, so this is a 3x3, find the determinant. Alright, rather than go through all that, this is actually going through all those different arithmetic. Alright. So let's take a look. Okay, the answer is 102. So 4, where did this 4 come from? Okay, so what they did was take a -1 times my row 1 and then plus my row 3. Okay, so that will actually come, what it really does is actually trying to make these entries into a 0 by down here. So basically what happened is the determinant, okay, use a number 4. So what they do is cover up row 1 and column 3. Don't use those numbers. So that will leave me with a 2x2 matrix right here. Okay, they use this number 4 right here and multiply the 2x2 matrix right here. That's how they find the determinant of a 3x3. There are different ways we can actually do this particular problem. Okay, so let me go to the calculator here. Rather than do the one, I'm going to do this one. Okay, I'm going to go to a 3x3 matrix. Alright, I'm going to go to edit 3x3. Okay. Now watch this, okay? Tell you what. This is what I'm gonna do. This might work, this might not work. Let me get out of this thing. This is the original problem, okay? I do this slightly different. Alright. This time, what I'm gonna do is I'm gonna use the number 5 right here. Okay, use the number 5 right here and multiply. Covered up the row 1 in column 1. So I'm looking at this particular 2x2 matrix. So I'm going to say 5 times the determinant, okay, of, I'm going to go back into the matrix, go to edit, alright, 2x2. I'm going to type in these 4 numbers, 4, 0, -4, and 4. Okay, get out. Second matrix, choose number 1. Okay, that will actually give me 80. Okay, so if I cover up row 1, column 1, that will actually give me this part right here. I use my 5 to do the multiplication. That will actually throw my answer off slightly. Now, okay, so the way how we normally do it is to do a 3x3 determinant. Okay, there's one particular value you got to use. So what they're trying to do is actually cover it up, make this nice number here into a 0. Okay, so they can actually take the determinant of this particular matrix. Alright, so the way I did it was using 5 covered up and using this 2x2 matrix. So that's a different types of problem. Now in the calculator, it's quite simple. In the calculator, you're just going to type in all the numerical values, and it will go through the computations for you. So what could happen is I might be thinking about other things here when I covered up my row 1 and column 1 doing this. I think that was for something else. I think I know what it is. I'll tell you this in a minute. Alright, so I'm going to get out. Go to matrix, math, choose number 1, determinant. Okay, 122. There you go. Alright, so they covered up row 1, column 3. Okay, and there's a reason why they covered up. There's a reason why they made this entry into 0 before they go on. So, can't remember exactly all the rules, or it's been a while since I did this actually by hand. Alright, same thing with this one. We can actually go ahead and you can actually key this in the calculator. Alrighty, so I'm gonna come back to this particular problem. Trying to find one where it's got a nice insert. Alright, problem like this one. Okay, so determinant, Cramer's rule is really good for us to use big problem like this. Okay, for 3 variables, 3 equations, you can actually write this out as a square. Just write out the coefficient matrix. Okay, so the way how you do use determinant is find a determinant. Okay, find a determinant of your square matrix. Alright, and then what you want to do is find a determinant for the x variable by covering up for the x variable. You covered up row 1, column 1, and so this bottom right here, the 2 by 2. Alright, once you find the determinant of that, you divide it by that number. Find the determinant of your problem divided by determinant of the x variable, and that will actually give you the x value. And do the same thing for the y variable. Okay, covered up row 2. Okay, if you cover up row 2, row 1, column 2. So you use these numbers. So there are different ways we can go about doing this. So for the z, you can actually cover up row 1 and 3rd column, and then find a determinant for your z, and then you divide them up. You actually give you the answers. Okay, that's actually what a Cramer's rule is. Because of technology, we can simply just key them into the calculator, and it will do the trick for me. He'll actually do the work for me. Alright, so this problem, just like the one I just showed you, if you key it in, you will find a determinant. Now there are other uses for determinant. One of the use is for the Cramer's rule. So I'm not asking y'all to use the Cramer's rule on the test, but I do expect y'all to be able to find a determinant, okay, of a 2 by 2 by hand at least. Alright, the very last thing I want to go over is actually went back and talk a little bit about systems of linear equations, okay, involving with inequalities. Beginning of chapter 10, I mentioned something about different ways we can actually graph different way we can solve system linear equations by substitution, elimination, or by graphing methods. So remember now, when we solve the system linear equation by graphing, this is actually 2 lines. So what we're looking for is the point of intersection. If the 2 lines does not intersect, let's say if they're parallel, that means I have no solution. If the 2 lines become the same line, okay, they become infinite number of solutions. Okay, so the fact that looking for the point intersection, okay, that concept is what we need here for the inequality. Alright, this is also called linear programming. What we want to do here is looking for a feasible region or solution region that will satisfy the given constraints. Okay, so if I'm involving with inequalities, all right, I need to find a region of points that will actually satisfy my inequalities. All right, what is so-called a bounded region is a region in which all the points lie within some finite distance of the origin. Okay, if it's bounded, what that means is I'm using equal to. Okay, unbounded means I have arbitrary, I have points that are arbitrarily far away from the origin. So it does matter. It does matter whether we are using equal to versus not equal to. So as you can remember, using equal to, we use a solid line. If we do not use equal to, we use the dashed line. So these problems is a lot like what you probably seen before in Algebra 2 class, with a little bit of twist here. So rather than just graphing these three inequalities on the same graph, okay, what we also want to do is find the minimum and the maximum value of the objective function and the points at which these values occur to the given constraint. All right, so basically we are going to graph these three and see where they're intersecting at. And the point of intersection, okay, by looking on the graph, the point intersection will tell me which one is the minimum, which one is the maximum. So we're going to take those coordinates and substitute into my objective function. So whatever I actually substitute in here, what comes out will be my minimum and maximum value. And where does it occur at will be the x value. Alright, so let's take a look. This is a little bit aggravating. Alright, first line. X greater than equal to 0. X greater than equal to 0. Who is x greater than equal to 0 referring to? Where is y greater than equal to 0? Well, y is greater than equal to 0 is referring to positive y value. Positive y value is referring to above the x-axis. So x greater than equal to 0 is referring to positive x value. Positive x value is to the right hand side of the y-axis. So if I graph my first line, okay, use red, positive x value, so that will be to the right hand side. Greater than 0 means to the right hand side of my y-axis. Hold that. Alright, y is greater than equal to 0. That will be above the x-axis. So let's give this a try. Okay, above the x-axis. Mute this color right here. Alright, so put the two together. I'm looking for a region that is to the right of my y-axis. It'll be about right here. You know what? Rather than do that, that stays permanent. I'm gonna use this one, the magic one. To the right of my y-axis and above my x-axis. So the part that overlaps to the right and above the two lines. Okay, the overlapping got to be this region right here in the first quadrant. Alright, so far my visible region, the region that the region of points that will satisfy the first two constraints are in the first quadrant, to the right and also above the x-axis. So that will be this region. Alright, now this one right here, the third one, the quickest way I can graph this is using the slope intercept form by solving for y. So if I get y by itself, that will be y is less than equal to, move the x over, negative x plus 5. So by using the slope intercept form, I know my slope m is -1. -1 means -1 over 1. My y-intercept will be at 0, 5. Okay. Alright, so far all the first two constraints I plotted. The point of intersection is at the origin. Okay. Alright, adding the third line here. Alright. Y-intercept 0, 5. That's my first point. Okay. Follow my slope down 1 to the right 1. Down 1. From the y-intercept to the right 1, that will be right here. So here it comes to my second line. Let me use dark green. Okay, I'm going to sketch it right here. Alright. So as you can see, actually my green line actually intersect with my blue line, which is x greater than or equal to 0, but you will eventually cross over the red line as well down here somewhere. So what I want to do, okay, is follow my slope and see where my green line intersect at the, where's my green line intersecting my red line with. Okay, I got to find all the point of intersection between all three lines. So this is 0, 0 so far. Okay, this is y-intercept. Follow my slope. Down 1 to the right 1. 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 So I'm supposed to intersect with my red line right here. So I draw my line slightly crooked. Okay, so I gotta change that. Okay, so that's the reason why I want to use the slope intersect form. It allows me to continue to use my slope to see what I'm intersecting it. Okay, now if you read the inequality, this is less than. Less than means below this green line. Below this green line will be down here. So if you put the three constraints together, it got to be to the right. My region is to the right of the blue, above the red, and below the green. So that region got to be this within this triangle, and this is my bounded region because I only have so many points in here. Okay, I only got finite number of points. Okay, within, okay, from the distance of the origin. These points is only so far from the origin. Okay, so I got 3 point intersection within this bounded region. Okay, so where is my minimum, where is my maximum value occur at? Alright, so the trick, write down your 3 points. 0, 0. Know what your 3 points are. Alright, 0, 5, which is up here. And this appeared to be 5, 0. Okay, so now the next step, substitute these 3 points into my objective function. So that will be, so if I substitute 0, 0, that will be 2 times 0 plus, 6 times 0 plus 2 times 0. So my answer will be 0. Now I substitute 0, 5. Alright, 6 times 0 plus 2 times 5. So that will be 10. Alright. Substitute 5, 0. Okay. 5, 0. That would be 6 times 5 plus 2 times 0. So that will give me 30. So this is the largest number, okay, for my objective function. So this got to be the max. Okay. And this got to be the minimum because that's the smallest one. So where does my maximum occur at? It occur at 5, 0, or you can enter as 5. Alright. My minimum occur at the origin. My minimum is 0, occur at 0, 0, that coordinate. Or you can say it occur at what x value, which is at 0. Okay. So in Algebra 2 class, you probably just graph the 3 lines and see where all the overlapping part between the line is, which is called the visible region. So this region is called the solution region or visible region because under the linear programming, if this is like, for example, a business kind of type of problem, so that means my business, this particular company might have certain number of constraints. They have to operate within those constraints. If they operate outside the constraint, they can begin to lose money. Okay, so what is the maximum, what is the minimum value, okay, they can operate within. Okay, you can think of a problem like that. Okay, not very common because this linear programming is actually a course itself at a 4-year college. Very interesting actually. Alright, this one got 4 different lines. Okay, so this is a little bit more aggravating. So let's give it a try. Same thing. X greater than equal to 0, that will be to the right of the y-axis. Alright, y is greater than equal to 0, that's above the x-axis. So again, I'm looking at I'm actually looking at the first quadrant again. Okay, so to the right and above is right here so far. Alright, ooh, this is a little bit aggravating. Okay, this one, solving for y. So that will be y that is less than equal to negative 6x plus 42. Ooh, that's big. Alright, my slope, negative 6 means negative 6 over 1. My y-intercept, okay, 0, 42. So by looking at the slope, I know my line is going downward. Okay, so 0, 42 is way up there. Okay, down 6 to the right 1. Okay, down 6 to the right 1. So that will take a long time just to figure it out. So what I'm going to do is I'm going to go to my y equal, and I'm going to grab this function, okay, to extract some points for me that I can actually plot within my coordinates here. Negative 6x plus 42. Okay, going down the hill. So I'm looking for some of these points I can use, because right away I see I'm cross over what? The x-axis. Alright, 6670. 6670. Six and 70. Five, 6, 7. Right here. Okay. Alright. Here comes to my green line. Alright, I'm going to connect them for a minute. Okay. Alright, this one right here. The third one. Oh, let me read this real quick. Y is less than or equal to. So this line going down the hill. So below this line got to be right here so far. To the right of blue, above the red, and it also got to be below the green. So I'm looking at this region so far still. Alright, solving for y. That's 5y less than equal to negative x plus 35. Alright, divide every term by 5. That will be 5 is less than equal to negative 1/5 x plus 7. So this is not bad. The x-intercept, excuse me, the y-intercept is at 0, 7. 0, 7 is up here. Okay. Follow my slope. Down 1 to the right 5. Down 1 to the right 5. Down 1 to the right 5. 1, 2, 3, 4, 5. Right there. Okay. Alright. Down 1 to the right 5. 1, 2, 3, 4, 5. Right there. Okay. So we kind of need to kind of sketch this a little bit, have an idea what's going on. So this one will be right there. Okay. 6, 6. Down 1 to the right 5. So I'm actually intersecting at this particular point. Now this particular point is going to be a little bit off. You know, I can't really tell exactly what that is. So now what I'm going to do is go to my y2 and type in the other function, and just to see what the intersection is. Parenthesis negative 1 over 5 x plus 7. Okay, ooh, here it comes right there. Alright, so what I want to do to find the point intersection in the graphing calculator, second calc, use number 5. Alright, is that the first curve? Yes. Is that the second curve? Yes. Guess? Yes. That there. Okay. Let's go up real quick. It says what? Round your answer to the nearest hundredth. Okay. If I round to nearest hundredth, there will be 6.03. Okay, let me write down these points. 6.03. Comma 5.79. Okay. Oops, sorry. So this is one point intersection, okay, between the black line and the green line. If you read this in inequality, this is less than. Less than means below this line. Alright, so let me take this point away. Let me take this point away. Okay, I'm taking away because what I'm interested in is really the intersection between all these points. Okay, the point intersection between all these lines, excuse me. Alright, let me take this point away, because this point I'm taking away is the point I'm using to help me to draw that line in the first place. Alright, to the right, above the red, below the green, below the black line. So this must be my visible region. Okay. Now, the point intersection. So I got 4 corners here. Okay. So what I'm going to do is test every one of these corners. Okay. Substitute these coordinates into my objective function and see which one is the largest, which one is the smallest. And that will give me my objective. That will tell me my maximum and minimum. Alright. So let's try one on the homework, just to see exactly how they go about doing this. I'm gonna find particular one, okay? Alright. This one. Let me skip that one real quick. So none of them has graph. So my graph was there to kind of give you a guide. Alright, this one is a lot like the one we did. Okay. Alright, if you look at tutorial, okay, so the way they still draw the graph right here, okay, just like what I showed you. Find the point intersection, okay, these corners, and then you test all those corners. Okay, so what we did was exactly correct. Now let me go back to practice. Let me see one. Let me see if I can find another one. No, let's try it again. Excuse me. Alright, this one. Looking for, my constraint here is between 0 and 2. So think about this, okay? X is bigger than 0, but that same X got to be less than or equal to 2. So I'm going to do that one in particular. I'm going to explain to you how to do this. Let's see how we're going to go do that. Excuse me. Okay. Oh, let's draw my lines. Okay, gotta be bigger than 0, but you also gotta be less than or equal to 2. Alright, so X bigger than 0, so that's to the right. So here's 1 point. See, excuse me, here's one line. Gotta be less than 2. So in that case, X is less than or equal to 2. So X equal to 2 is a vertical line at 2. Less than 2 means to the left of it. So my X is in between 0 to 2. Okay, so far right here is my region. Same thing with the Y. Greater than 0. Greater than 0. Y is bigger than 0. That's a horizontal line. Okay. On the x-axis, need to be above it. But at the same time, I'm also looking at y is less than or equal to 3. Y equal to 3 is a horizontal line at 3. But it got to be less than 3, bigger than 0. So that will be in between. So between the blue line, also got to be between the red line. So that will actually give me one tiny little rectangle right here. Okay. Now come with this last. Come with this one, last constraint, solving for y. That's 4y less than or equal to negative x plus 12. If I divide every term by 4, that's negative 1/4 x plus 3. Alright, so the y-intercept is at 0, 3, 1, 2, 3. That will be the same point intersection. So this one point is gonna be intersected by 3 different lines. Down 1 to the right 4. Down 1 to the right 4. 1, 2, 3, 4. That will be right there. Okay. Do a black line right here. Okay. Alright, if you read the inequality, it says, you know what, I'm going to do purple. There you go. Y is less than or equal to. Less than or equal to means right below here. Okay, so out of all the lines together, my boundary region is actually just this little tiny space. I got to operate within this space. So let me move this one, put it over here. Okay, that point is actually intersected between the purple and the blue, and this blue line is actually y is what? That's y is less than equal to 2. Excuse me, x is less than equal to 2. Okay, so what is that point of intersection? And this is where it's hard, because you cannot graph a vertical line in the graphing calculator. So how are you going to go about see what the point intersection is? It's real simple. You can say x is equal to 2, and you can line up with the purple line. X plus 4y is equal to 12. Okay, and solving for x and y using the system of linear equation. So I'm gonna go to my matrix. Okay, this is gonna be what? 2 by 3. Does that make sense? Because I can't graph it, so I'm gonna go to my matrix C and do this. 1, no y means 0, and a 2, 1, 4, 12. Now I'm going to go back to the matrix, go to math, and go to my row reduced echelon form and see where my point intersection is. Did I say 2 by 4? No. Oh Lord. 2 by 4. 2 by 3, excuse me. 1. Oh Lord. Let's go back. 0, 1, 0, 2, 1, 4, 12. Okay, so the point intersection got 2 and 2.5. There's my x and y value point intersection. All right, this is 0, 0 here. This is 2, 0 here. And this one right here is 0, 3. So I will plug in all 4 corner. I'll plug in all 4 corner, okay, and to find my maximum and minimum. Alrighty. So with this one, we will end our lecture video series for the college algebra here at Northeastern College. Alright, thank you for watching.